solve tan x equals minus 1.5 for the boundary between 0 degrees and 360 degrees. So that's what that meant. The smallest is 0 degrees and the largest is 360 degrees. So x is in between them. Give answers to one decimal place. So we can start by saying tan of x equals, tan of x equals minus 1.5, but tan is also opposite over adjacent. And sometimes it's also called sine of x over cos of x. So to find the actual angle we're talking about here, x, so we need to divide both sides by tan. So if I divide that by tan, I get x equals 1 over tan. If you're dividing, you're multiplying by 1 over. And then so the times 1 over tan times minus 1.5. In indices, 1 over something is something to power minus 1. So therefore, this is tan to power minus 1 times minus 1.5. So that's what x is. So if you get a calculator and just bring it there, and we turn on the calculator, you press shift tangent and minus 1.5, close bracket. So that gives x equals minus 56.3 degrees. So this is the angle we're going to use to solve that problem. So one way of solving this is to use cast diagram. In cast diagram, this is the first quadrant, that's the second quadrant, third and fourth quadrant. And we measure the angle from 0 degrees all the way back to 360 degrees in anti-clockwise direction. The question is saying we need minus 56.3 degrees. So if I get my ruler and measure the 56.3, obviously using protractor. So what I'm doing is just a rough estimate now. So let's assume this is the angle here. Obviously it's bigger than 45 degrees. So let's say that's the angle here. And that's minus 56.3 degrees. And if I project this point here, that's on the circumference, and that point is your x and y. And if I project the x and y down to the axis, x-axis, so this one is what we called minus y, right? Because it's negative, it's below 0. And minus y is minus sine x, because that's a negative direction. And this one here, the distance from there to there is what we call the cos of x, and that's positive. So that's what makes it negative, because tan is sine. Tan is sine over cos, but this is minus sine x. So tan x is sine x over cos x. Sine x over cos x is what tan x is. And this is minus y. That's why it's minus sine x, because y is always sine x, because I'm using unit radius. So this is 1. The radius is 1. So r equals 1, unit radius. And so this is using unit circle. So if I write it here, unit circle. And what I meant is radius equals 1. And this is positive x, this is negative y. And y is always sine. You can see the opposite here is y. So that's y over x. and the adjacent is x, and the hypotenuse is radius. So, but what I need to do is also extend this angle to the second quadrant. So if I just extend that, what that meant is this angle is also 56.3 degrees. Alternate angle. The alternate angle are equal and opposite. So if that's the case, if I project, this is also x and y coordinate. So if I project it down, this will be y, which is sine x, and this distance here will be x, which is cos x. Again, cos is negative and y is positive. So positive over negative, we need this angle because we're looking for minus 1.5. So we're looking for this and this one. Here, y is positive. Y will be positive if I projected that to that side here. And then draw that line. Y will be positive, right? And x will be positive. So that will give us positive. For tan, it would be 1.5 for tan. This one will be, for tan, it will be minus 1.5 for tan. And this will be, also for tan, will be minus 1.5. And if I projected that here, and that there, and this will be positive 1.5 for tan. So we're looking for negative 1.5. That's what the question is saying, and negative 1.5, because minus cos and minus sine will be plus tan. Here will be plus cos plus sine, so that's sine x, and that will be plus tan, so we don't want that. Here is minus cos plus sine, so sine plus over minus will be minus. So that's why we're looking for these two angles. And this angle here, then, we need to measure from 0 degrees all the way to there. And when you do that, that angle, you take it away from 180. So if we take it away from 180, sorry, 123.7 degrees. So that's 123.7 degrees from there to there. And also, because we need this one as well, so those are the two angles that we need. We need that and this one because there's the negative minus 1.5 and that's minus 1.5. So we need to measure also from this angle here all the way to there. And that will be 360 degrees minus 56.3. That'll be 303.7 degrees. So the x values we need are 123.7 degrees and 303.7 degrees. So that's done using cast diagram. Another way to do this is to use the tangent function. So I draw a straight line there. If that's 0, that's y. And minus 90 is here, and that's 90. So that's pi over 2 minus pi over 2. That's the line of asymptote for tangent function. This is the line of asymptote for tangent function. And it goes through 0. This is y-axis here. And this side will be x-axis. And so it will be going that way, all the way, approaching 0 there, 0 degrees, and all the way to line of asymptote here at 90 degrees. So that's a tan function, and it repeats every pi. So that's a pi. Next pi, the next one along will be pi here, and then 3. So that's 3 pi over 2. And as I said, this is 90 degrees minus 90 degrees, 0 degrees plus 90 degrees. That is 180 degrees, and this is 270 degrees. And so that's another line of asymptote for tan function. And it will go through 180 degrees. So tan of 180 degrees is 0, and all the way to line of asymptote at 270 degrees. So that's 2 periods for tangent. And we could do another one because we need to go all the way from 0 degrees to 360 degrees. So we need to go from there to there. So that's 360 here, because every half a pi. And so that will go from there all the way to 2 pi. So that's 2 pi, and that's 360 degrees. Now, what we're looking for is minus 1.5. So this is 0. That will be plus. Minus 1.5 will be somewhere here. So that's minus 1.5. And what we can do is just draw a horizontal line that goes straight all the way. So this is what we just got. Minus 56. X equals minus 56.3 degrees. So that's that one here. This is minus 90 degrees. That's minus 56.3 degrees. And if we don't want that, because we want from 0 to 360 degrees. So we keep following the line, and the next point along is going to be 90, right? And this is 180 degrees. So that means 180 take away 56.3 will give you 123.7 degrees. So that's 123.7 degrees. And the next one along is going to be before you get to 360 degrees, right? It can be equal to 0 or 360, but not beyond, or not less, because that's what the boundary condition is saying. So here will be 360 minus 56.3, and that will be 303.7 degrees. And that's how you can find the function using a tan graph. So that's tan, y equals tan graph. Or you could find it using the cast diagram.